Hello guys, welcome back to Math Zone African Motives. Still on our mathematics for grade 11, and this is a revision that we're gonna have on our trigonometry. That is, we need to understand how questions are given and how are you supposed to attempt those typical questions. So make sure that you prepare yourselves as much as you can. All right, so this is a typical exam question, as we can see. That is the basics. These are the basics of our trigonometry. All right, the marks are on this side here. Let me try to do this so that you can see everything. All right, so these are the typical questions that we might have. So we need to understand all these typical questions. All right, so then we are given on question number 2.1 in fig below. We are given the coordinates of the point P. This is the point P is given as K3. Are given with POX, which is angle. POX is given as what? As alpha. So this is the angle that we're given. That is POX. POX. All right. That is given as what? As alpha. This whole angle here. So in actual sense, we are supposed to have a point referred to as what? As X. Not to say they are referring to this X here. No, there's supposed to be a point somewhere there referred to as X, like P or X. All right. So given the length of OP from O to P, this length is given as what? As 5 units. All right. So this is what you understand from the diagram. This can give us a right angle triangle if we just extend here. And we understand that here we've got from the point P, which is K3, we've got the X value and the Y value there. So the X value is for the X axis, which is this K here. It's representing the X value. The 3 is for the Y, meaning to say it's representing the Y values on the vertical line. So that is where we have our 3. So this is the presentation of how our triangle is supposed to be. And as we know that on this side of the x-axis, our values, they are positive. On this side, they are negative. So the question here is that determine the value of, all right, 2.11, the value of K. Determine the value of what? The value of K. So in order for us to have the value of K, as we can see on our diagram here, we can see that we've got a right-angled triangle, right? This is a right-angled triangle, which is at what? At 90 degrees. So we can use the properties of what? Of a right-angled triangle, since we understand that from our properties of a right-angled triangle, from our Pythagoras theorem, all right? So this is 4.11. All right, so you're gonna have from our Pythagoras theorem. All right, this is 2.1. Where am I getting the 4.11, guys? All right, so where am I getting this? So like I was saying, this is 2.11. Okay, so in order for us to have the value of K from our Pythagoras theorem, we understand that our R in this case is equivalent to X squared plus Y squared. That is the X and the Y value squared from our Pythagoras theorem. So what we want in this case is the value of K. So you can even write this side, right? On the left-hand side, X squared plus Y squared is equal to R squared. All right, so the X there is the part represented with what? With the K, the X values. So that's K squared plus the Y values represented by what? By 3. So this is going to be 3 squared is equal to R squared, which is our hypotenuse, which is what? Which is 5. So that's 5 squared. So that means you're going to have K squared plus 3 squared, which is 9, is equal to 5 squared. You're going to get a 25. Then you transpose 9 to the other side of the equation. That will be a negative this side. So you're going to have a negative 9 this side. All right, so that's 25 minus 9, which is going to give us a 16. So to obtain the value of K, introduce the square root to remove the square that we are given here. So as we know that the square root of any number is what? It's a plus or minus. So the square root of 16 is a 4, but you're going to have a plus or minus. So what is the exact value of K? We have to compare with our diagram on the Cartesian plan. Like I was explaining, on the left-hand side of our Cartesian plan, our X values are negative. On the right-hand side, they are positive. So meaning to say our K is going to be a negative since it's on the what? On the left-hand side. So therefore, our K in this case is going to be a negative. So therefore, our K is going to be a -4. So meaning to say here, we have got what? We have got a -4 there. All right, that is how you can find this. You can use this concept of your Pythagoras theorem. Okay, then the next question was to find the value of tan alpha, right? That is on 2.12. We have our diagram here and everything is complete. This is the tan of, this is the angle of alpha. So as we understand from our mnemonics, SOHCAHTOA concept, that's our SOHCAHTOA concept, we do understand that the tan of the angle, which is in this case referred as the tan of alpha, is taken as the opposite over what? Over the adjacent. So according to this alpha, we are talking about the angle that is inside of the triangle. It represents the same properties as this alpha, the angle inside of the triangle here. So according to this angle, this side is our opposite, and this is our adjacent, where the 90 degrees and the theta are found, and that is our hypotenuse. So in this case, we need opposite. What is the opposite? The opposite there is what? 3 over the adjacent, which is the value of K, the one that we got as what? As a -4. So you can leave it like that, or you can write this as -3/4. It's one and the same thing. Okay, let us check the other part of the question. This one is the cos of 90 degrees plus alpha. All right, so these are from our complementary angles. So remember that from your complementary angles, the properties of the cos of 90 degrees plus alpha is test that the cos of 90 degrees plus alpha like this is equivalent to the negative of sine alpha. Thus, cos of 90 degrees plus alpha from the concept of our complementary angles, like I was explaining. If this is A and B, we understand that the sine of A is the same as the cosine of 90 degrees minus A. But when it comes to an addition, whenever we've got a cos, the cos of 90 degrees plus A, it lies in the second quadrant, and there in the second quadrant, it's a negative value. So that's why our sign carries a negative. So it's minus sine what? Minus sine alpha. You're supposed to know your identities, all right? So that means we've got minus, your ratios in this case, minus the sine of alpha. What is the ratio for sine? We are back now to the ratio of the sine, the opposite over the hypotenuse. So according to this, the opposite is what? The opposite there is 3 over the hypotenuse, and our hypotenuse is what? It's 5. So meaning to say our answer is going to be affected by the negative that is outside of the bracket. So you're going to get negative 3 over 5 in that case. All right. So we have to be very, very careful how the information is given. How are you given your information, and how are you supposed to attempt that typical question? All right. So that was it. Then in this case, they need us to find the exact value of alpha, the angle alpha. As we can see, the angle alpha is an obtuse angle. This is the angle that lies in the second quadrant. So it's an angle that is greater than 90 degrees, an obtuse angle, this alpha that we are talking about. So alpha is an obtuse angle. So how do you find this angle alpha? Remember, we are now solving the equation, finding the value of alpha. We are now solving the equation. All right, so that was 2.13. All right, 2.14. Right, it's like I mixed something here. 2.12, it's like 2.22, 2.13. This is 2.13. Guys, very sorry for this. I mixed this 2.12, 2.13, then 2.14 on this one. All right, so what are we going to do in this case? Like I said, in order for us to have the angle alpha, what does it mean? You are solving. To determine this is to solve for an angle. We are now talking about solving of the trigonometric equation. It's now an equation that must be solved. So what you do is that you take any part where you are given something that is already complete. You can use the sine. You can take the ratio of sine. You can take the ratio of cos. You can take the ratio of whatever that you want. All right, let's say I want to use the ratio of sine, whereby the sine of alpha is opposite over hypotenuse. And according to this, opposite is 3. Hypotenuse is what? It's 5. This is what I'm going to have. Sine of alpha is what? The sine of alpha is 3 over 5, opposite over hypotenuse. So you're saying the sine of alpha from our diagram gives us 3 over 5, opposite over hypotenuse. So what you do in order for you to have the angle, what you're going to calculate is the first is the reference angle. So how do we calculate our reference angle? We can even write this as the reference angle like this. So the reference angle is the one that you determine by finding arc sine of this. You bring sine this side and to be written as what? As arc sine. So this will be arc sine 3 over 5. So thus you're obtaining what? The reference angle from there. All right, I'm going to show you the meaning of this reference angle and how to apply your reference angle. Okay, let us take our calculator. This is arc sine. It's a shift sine. So that's shift sine 3 over 5, like this, shift sine 3 over 5. And this is going to give us 36, this. So you're going to round off to 2 decimal places, which is 36,87. Or you can do that on your calculator, shift, set up. You go to fix on number 6, then to 2 decimal places, you press 3. So this will be 36,87. So there we are obtaining 36,87 degrees. This is what? Our reference angle. So you have to ask yourself now to say in this quadrant where we are, remember we are talking about what? A sign that is being a positive, the sign of alpha being a positive there. So how are we going to determine the angle in the second quadrant? Because this is where our angle lies. Remember, in the first quadrant, alpha is equal to the reference angle. The angle that you want. If it was in the first quadrant, you're going to equate to the reference angle. But in the second quadrant, where this angle lies, the exact angle, the actual angle that you're supposed to calculate, which is alpha, is equal to 180 degrees minus the reference angle. You subtract the reference angle because this is going to be your reference angle. So you have to subtract to remain with this angle. You have to subtract from 180. If it was in the third quadrant, you add your alpha was going to be 180 degrees plus what? The reference angle. If it was in the fourth quadrant, your alpha was going to be 360 degrees minus the reference angle. You need to know the quadrant that you are in. Which quadrant are you working with? We are in the second. This is the first, the second, the third, and the fourth quadrant. All right? So that is the condition. So we said in the second quadrant, the exact angle alpha is going to be 180 minus the reference angle. So therefore, our alpha here is going to be what? Our alpha is going to be 180 degrees minus the reference angle, which is 36,87 degrees. So if you subtract this, you are going to obtain 143.13 degrees. So this is the value of alpha. All right. So someone is asking, why can't we even use the tan that we can see? Because we can see that the ratio of tan is already there. We calculated tan alpha is minus 3 over 4. It's true. We can use that. We can use that. Okay, let me show you. We can use this. Remember that we obtained that the tan of alpha is what? 3 over minus 4. The concept is still going to be the same. What you need is what? Is the reference angle. So from the tan of alpha, you are going to calculate the reference angle. The way that you calculate the reference angle is from the trig that you're given. The trig here is the trig of what? Of tan. So on the other side is going to be arctan. So it's going to be the arctan. But you don't consider the sign. Remove this sign. The sign there, it shows that where tan is, it's a negative. Remember, in the second quadrant, this is the quadrant for sine from the cast concept. This is the quadrant for sine. Tan there is a negative. So that's why you see there's a negative, because if you find any value here, cos negative, tan negative, only sine is positive. So this is what this negative represents here. So when you are calculating, don't use the negative because it just indicates that tan there's a negative. So it's just going to be arctan 3/4. Just like what we did, guys, on the last question, shift sign. So this one is going to be shift tan. It will be arctan 3/4. You're going to get the same angle of 36,87 as your reference angle. Then to find the actual angle, you consider the quadrant where the angle lies. And we said in the second quadrant, our alpha is given as what? Our alpha is given as 180 degrees minus the reference angle. You subtract the reference angle from 180. So still, you're going to get the same answer as this. That's how our questions are given. All right. So that was the question here. All right. So question 2. Question 2.1 is actually fine. And this 2.2 has nothing to do with 2.1. So let us just remove this. All right. We are given now on question 2.2, given angle A and B. So there we've got angle A and B in this case. Are what? Complementary angles. We have been talking about complementary angles. What does it mean? If I add the angle of A and the angle of B, I must get 90 degrees. These are two angles which add up to 180. Complementary, two angles which add up to 180. Supplementary, two angles which add up to 180. But complementary, they add up to 90. Complementary, 90. Supplementary, 180. So for the supplementary, they add up to 180. Two angles which add up to 180. They're supposed to be two, not three, but two angles, only two, which add up to 180. So meaning to say, if they are angles, another angle is A and another angle is B, maybe they are on a straight line. We know that angles on a straight line is equal to what? 180. So those angles that are, those two angles on a straight line are called supplementary angles. But here they are saying they are what? Complementary. Two angles which add up to 90 degrees. All right. What is it about these angles? All right. 7 cos A minus 3 is equal to 0. Determine without the use of a calculator the value of. Okay, this is what we want. Okay, let's take this information. We said A and B are complementary angles, all right? So that's 2.2. So we said angle A plus angle B should give us 180. That is to mean that they are what? They are complementary. And we are also given that 7 cosine of A minus 3 is equal to 0. What is it that we can have here? All right, if A and B, they add up to 90, it means we can form a right angle triangle. Why? On a right angle triangle, one angle is 90 degrees. That's why we are calling it what? A right angled triangle. And it states that the remaining angles, they are going to be what? Equal to 90 because they are going to be complementary. Remember, angles in a triangle, they add up to 180. So if we subtract now this 90, this one from 180, it's going to be 180 minus 90 will remain with what? 90 degrees. So it means these two angles that we are seeing here, they are supposed to add up to 90 degrees. So that 90 and 90 gives us what? 180. So this is your angle A and your angle B. You can name it the way that you want. And this one we do not know. You can even call it C. What is important is that they are on a triangle. That is the only condition. They are on a right angle triangle. These two angles, they add up to 90 degrees. That is the condition. They are supplementary angles. If this is 90 degrees, only for a right angle triangle. That is the condition. So it means we can apply our trigonometry. They are just avoiding us they're just avoiding to tell us to use the application of our trigonometrical ratios straightforward by using this concept. It's on a right angle triangle. This is what we see. So on a right angle triangle, you can have the ratio of the cosine of A and relate it with A on our diagram. What does it mean? Okay, let us have our ratio. 7, the cosine of A minus 3 is equal to 0. You can transpose minus 3 to the other side. It's going to be a positive 3. Divide by 7 by 7. That means we're going to have the ratio for the cosine of A as a fraction. The cosine of A is going to be given as what? As 3/7. What does it mean? Remember from our SOHCAHTOA concept, from our mnemonics, we have got this part of the SOHCAHTOA concept. The cos is adjacent over what? Hypotenuse. So meaning to say we are given a ratio because this is on a right angle triangle, and on a right angle triangle, that is where we use what? Our trigonometrical ratios. So what it means, according to the angle of A, what is the adjacent? This is the adjacent side. A and C, they are sitting together on this line. So this is our adjacent, which is 3. 7 is the hypotenuse, the longest side here, which is what? Which is 7. So this is a 7. So this is where this information was playing a role. It was going to give us a right angle triangle like this, and we can substitute the information according to this ratio. We can fill in, and we can even calculate the third side because this is a right angle triangle, and we know about what? Our Pythagoras theorem, right? The sum of these two shorter sides, a squared plus b squared, should be equal to r squared. A and b are the shorter sides, so we want this side, we can just write as a squared plus b squared, which is 3 squared, is equal to r squared, which is the other side squared, which is the hypotenuse squared. Okay, what is the value of 3 squared? 3 squared is 9, but it's going to be subtracted this side. So it's going to be 7 squared minus 3 squared. So a squared is equal to 3 squared from 9 squared, from 7 squared. 7 squared, guys, is 49, and we can subtract 49 minus 9. Okay, let me just write 49 minus 9, and that is going to give us what? A 40. So that's a squared is equal to a 40. To find a, introduce the square root both sides. So a is going to be equal to the square root of a 40. That's this side that we are seeing here is equivalent to the square root of what? To the square root of a 40. So that is the information that we are given about this, this ratio, this condition that they were trying to write 7 cos of this. It was for us to complete our triangle. After completing our triangle, that's where now we bring our question. What is the question? Because we now have a complete triangle. The question is we are supposed to find 7 cos B minus 3 tan A. All right, let us write it down. 7 cos B minus 3 tan. So this is our question. We are supposed to calculate 7 cos of B minus 3 tan of A. So we are simply substituting 7 times what is the cosine of B, because we have our B here and we can even use the ratios because it's a right angle triangle. The ratio, of course, is adjacent over hypotenuse, but according to B now, according to B, what is the adjacent? The side that lies together with what? With C. On this one, which is 40. That is our adjacent. The angle B and the angle C, they are adjacent to each other. So the side that lies there is what? The adjacent side. So that's our adjacent over hypotenuse. So the adjacent is the square root of 40. Over the hypotenuse that does not change, that's a 7. Minus 3 times the tan of A. We are now back to angle A. The tan of A, all right, from our SOHCAHTOA concept, remember a tan, it's opposite over what? Adjacent. According to A, this is the opposite side according to A. This is our opposite side, which is what? Which is the square root of 40. Over the adjacent, according to A, we talked about this before. We said this is our adjacent, which is 3. A and C, they are sitting next to each other here. So that is what we have. So as we can see, guys, this is same as 7 over 1. This is same as 3 over 1. So the 7 and the 7 will cancel, we get a 1. 1 times the square root of 40. That is the square root of 40. Minus 3 and 3 will cancel, remain with a 1. 1 times the square root of 40 is what? The square root of 40. 2 minus 2 is a 0. 3 minus 3 is a 0. What about the square root of 40 minus the square root of 40? It's a 0. These two are the same. So if you subtract 2 terms that are the same, you get a 0. X minus x, it's a 0. Not 0 square root of 40. This is 0, 0 like that. Just a 0. There's nothing like 0x. 0x is what? It's a 0. So you write that as a 0. That is the idea there. Okay? So they will test you this. Do you know how to use or to apply your right angle triangles, the use of your trigonometrical ratios, are you able to apply those trigonometrical ratios? So these are some of the questions that you might have. Just need to attempt as much questions as you can. All right, let us check the other part. Simplify. All right, this is 2.2. There we are given to simplify, 5 marks on that. All right, so this is what you simply do on the simplification. This is 2.3. I'm not going to rewrite this. I'm just going to take each stage as it is. All right, let me just write the sine of 210 degrees times the cosine of 790 degrees times the tan of negative 330 degrees, like this. Everything is affected by what? By the sine of 160 degrees. All right. So you have to understand your trigonometric application from your angles, positive angles, reduction of angles, this and that. So here it's a straightforward question. You just need to know the properties of your angles. Where does the angle lie in terms of our quadrants? Remember, from the cast concept. Or you can use all students take calculus. Or you can take this, the cast. All right. We know that in the first quadrant is from 0 to 90, 90 to 180 in the second, 180 to 270 in the third, 270 to 360. Where all of the ratios are positive in the first, in the second only sine, in the third only tan, in the fourth only a cos. So there we must know where the angle lies. Where does 210 lie? 210 degrees is greater than 180. This is where we have 180 degrees here. This is where we have 270 degrees. So 210 is in between. So meaning to say this angle was going to lie in this quadrant. That is where our angle of 210 lies in the what? Third quadrant. And this is the quadrant for tan. There, sine is a negative. So whatever that we are going to get for sine in this case is going to carry what? A negative, because this is the quadrant for tan. Tan here is what? It's a positive. But we are supposed to write to reduce this into the acute angle, the reference angle. How do you determine, how do you have that value? All right, so in the third quadrant, the angle is past 180 degrees. So to find this angle that is remaining, this, which is our reference angle, this one, is 210 degrees minus the 180 of the straight line. So you subtract or you remove the straight line to remain with this angle. So that's 210 degrees minus what? 180 degrees. And that is going to give us 30 degrees. So it's going to be minus sine what? Minus sine 30 degrees. Like I said, a sine is going to carry a negative. This is not the quadrant for sine. It's the quadrant for what? For tan. Tan, there is the one that is the king. So the rest, they carry negatives. All right, times the cos of 720, or 790. If we check 790 is past 360 degrees. It is more than 360. So how do you calculate this? You subtract 360 degrees until we get an angle that is in between 0 to 360. Remember, the angle theta is supposed to be taken to be greater than or equal to 0, less than or equal to 360 from this quadrant, so that we can compare our values. So this is what you do. You subtract this 360 degrees, you subtract this. So this, let's get back to the normal mode. So that's 790, like this. You subtract 360, which is a complete revolution. So after subtracting, after removing a complete revolution, we are getting 430, which is still more than 360 degrees. So what do? We have to subtract again. So if we subtract 360, what do we get? We get a 70. As we can see, a 70 is what? A 70 is less than 360. So this is the angle that they are hiding here. Instead of them giving us as cos 70, they are hiding with this number that they are writing here. This is just equal to what? To the cosine of 70. This is the equivalent angle. So you subtract that angle up to the angle that is in between what? 0 to 360. If the angle is not in that interval, if it is more than 360, you subtract again. All right. Let's move on to the other angle. Times the tan of minus 330 degrees. Remember how you take your negative angles. Negative angles are taken in the what? In the clockwise direction like this. Positive angles are the ones that we take in the anti-clockwise. That's why 210, I indicated it like this. It indicates a positive angle. So for a negative angle, this will be 0 here, minus 90, minus 180, minus 270, minus 360. So as we can see, minus 330 is going to be in between this interval. This is where we get our minus 330 degrees, between minus 270 degrees and what? And minus 360 degrees. We are taking our angles in the clockwise direction. They are taken as negative. This is 0, this is minus 90, this is minus 180. They are taken as what? Negative angles. So what is the angle equal to this? The angle equal to minus 330 degrees is the angle that is taken from the same point in the different direction to the same point of our final here. We took this in the clockwise direction and we said these are negative angles. We are going to take going the other way until we meet this line, until we meet this one, this line. Where we meet this line, we stop. That is the angle that we are supposed to calculate, this one. And it's a positive angle because it's going in the what? In the anti-clockwise. Remember, this angle represents minus 330 degrees. So out of the 360 degrees, what is remaining? 360 degrees, 360 degrees. If we remove 330 degrees, we remain with what? With a 30 degrees. So the angle that we have at this point, guys, the angle here is at 30 degrees here. There is a 30 degrees, which is what? Which is a positive. That is the idea there. All right, let's remove this. There is an angle of 30 degrees, which is equal to this whole angle of what? Minus 330. 30 degrees and minus 330, they are equal in their properties. They are equal in everything. The cos of minus 330 is equal to the cos of 30. The tan of minus 330 is equal to the tan of 30. Prove that with your calculator, you see. They are equal angles. Okay, let me do this. Let us just say maybe sine 30 degrees. Sine 30 degrees is what? Sine 30 degrees gives us a half. Okay, sine minus 330 degrees, what do we get? We simplify this, a half again. So this is what I'm trying to say. These two angles are the same. They have the same properties. So in place of us writing minus 330, which is the angle that is not a part of our interval, we use the reference angle, which is 30 degrees. So this is the same as the tan of 30 degrees. So always write your answers as acute angles, which it represents what? The reference angles. All right, we move on to sine 60 degrees, right? So we have to write this as a smaller angle. We have to reduce this. Which quadrant do we have 160 degrees? 160 is more than 90 degrees. And as you can see, it's a positive. It means we are going in the what? Anti-clockwise direction. So it's more than 90 degrees, but less than 180. This is 0, 90, 180. So it's more than 90, but less than 180. That is where our angle is supposed to be in the second quadrant. So this is what we're going to have. That is our 160 degrees. So you just have to ask your question, what about the angle that is remaining here, which is our reference angle, this acute angle? So it's 180 minus what? Minus 160. So if we subtract this from 180, we get what? 20 degrees. So it means there's an angle of 20 degrees that is remaining here. That is the angle that we want. So we compare now with the sine. What are the properties of sine in this quadrant? Sine there is what? It's a positive from the cast. This is for sine S. Sine there is what? It's a positive. So it is going to be written as the sine of the acute angle, the sine of the reference angle, as a positive as it is, because we saw that in this quadrant, sine remains positive. So this is where we are now. Is there anything familiar here? Is there anything familiar on this information? What am I trying to say? Is there anything that you can cancel? There's nothing. All right, but there's something that is happening here. I want you to see something here. Okay, we can change this, a cos, to be a sine, or we can change a sine to be a cos. Either way. So as for me, I'm going to change this cos on top here to be a sine. How? Remember that we said from the cos of theta, it is equal to the sine of 90 degrees minus theta from our complementary angles. Remember our complementary angles. So if this is the case, it means the cos of 70 degrees is the same as the sine of what? 90 degrees minus 70 degrees. And what is 90 minus 70? 90 minus 70 is what? It's sine 20. So the value for cos 70, guys, this value that we see for cos 70, this one, if you use your calculator and see, you are going to see you get the same answer as the sine of 20. They are the same. So we are going to remove this with the equivalent, which is the sine of what? Of 20. So this is going to be minus the sine of 30 degrees times the sine of 20 degrees times the tan of 30 degrees. Everything over what? Over the sine of 20 degrees. So like I said, these two can be written the same. As they are the same, we can cancel them. We can cancel this, we can cancel this. Meaning to say, we are just left with the minus sine of what? 30 degrees times the tan of 30 degrees. That is what we are just left with. And there is no relationship that can cancel anything. Yes, we know that the tan can be written as the sine of 30 over the cosine of 30. But what are we going to do if we multiply this to minus sine 30? There's nothing. So we are limited now. But if we check these two angles, I mean, if we check the angle that we have there, 30 degrees, it's not just a normal angle. These are special angles. Remember, from your special angles, we can simplify these values. So I said from our mathematics grade 10, either you know the properties of your special angles to say, this is 30 degrees, this is 60 degrees. We know that this is 1, this is going to be 2, and this will be the square root of 3. We understand this. Whether you know these properties or not, use your calculator if you are stuck. At this condition, no one, not even one, is going to know that you have used a calculator there. Because the answer that I'm getting here with someone we have used these special angles and the one that have used a calculator is the same. The sine of 30 degrees from the opposite over the adjacent, over the hypotenuse. Remember, sine from the SOHCAHTOA concept. It's opposite over what? Hypotenuse. Opposite in this case, according to 30 degrees, is what? The opposite is the square root of 3. Over the hypotenuse is what? Is 2. All right? Guys, why am I having a... Okay, I mean, hey, guys, you see now, this thing of rushing, now I get these angles different. Now I'm surprised to say, why is it this is lying? So if you do not know this, you'll see that, oh no, this is lying. Remember, this is 60 degrees here. Yeah, this is 60 degrees. This is a 1. This is square root of 3. This is 30 degrees. Yeah, sorry for that. Okay, can you just correct this? Okay. So like I was saying, the special angle that you get from your calculator, that's why I was saying use your calculator there, because you see this confusion thing. It can just happen like that in exam. You're in a hurry, you just write this and you, okay. But the answers are supposed to be the same. So the sine of 30 degrees opposite over the hypotenuse, the opposite is 1. The hypotenuse there is what? Is 2. According to this is opposite. This is the longer side, the one that faces 90 degrees. This is the same answer that you get from your calculator. So just use your calculator there. Minus 1 over 2 times the tan of 30 from your calculator, you're going to get square root of 3 over 3. No one is going to know that you have used a calculator or not. Multiply this on your calculator again, you're going to get minus 3 over 6, minus square root of 3 over 6 like that, all right? So that's the tricky part. It does not mean that when the question is saying do not use a calculator, then you are stuck, you are saying I'm not going to use the calculator. The question is saying this and that. No, it's not like that. They are stages that cannot be counted that someone has used a calculator or not. All right, let us check this one. This is proof that, prove that. All right, we simplify this. Prove this, and that is 4 marks. All right, let's try to prove here. So this is the identity that we are given. The left-hand side is given as the sine of x. So that's sine x minus the sine of x times the cosine of x, everything over the cosine of x minus 1 plus the sine squared of x. This is equal to the tan of x. Okay. Remember, on the proof, you are supposed to choose a side to work from. Are you going to work from the left-hand side? Are you going to work from the right-hand side? All right. Always choose the complicated side when it is a condition like this. So in this case, let's say I choose to work with the left-hand side, which is the most complicated. As you can see, that's where we have a lot of things to consider there. So the left-hand side, we are given this is equal to the sine of x minus the sine of x, the cosine of x. Just take it as it is. Everything over the cosine of x minus 1 plus the sine squared of x. Okay, what can we do here? So proving, it does not mean that you know the answer. All right, sometimes they might ask you to simplify. The same question that you're given to prove this time, they might ask you to simplify it. Where you are not given the answer, you're just supposed to simplify. All right, so this is what you do. You just test how best you can do. Are we gonna remove this 1 here? Because there is an identity that represents 1, isn't it? We know that 1 is equivalent to the cos squared of x plus the sine squared of x, or just sine squared x plus cos squared. But if we substitute here, I want you to see what's going to happen. This is going to be cos x. Then we have got this identity multiplied. All right, it's going to be like this. The cos of x minus 1. Take note, this is minus. So it's going to be minus. What is 1? 1 is represented by this, which you said you can even write as sine squared no matter the way that you want. So it's going to be the cos squared of x plus the sine squared of x, like this. And there is plus sine squared, this one, plus this sine squared. Let's see what's going to happen. If we expand, this will be going to cos x minus cos squared x multiplied by negative here. That will be a negative sine squared x plus sine squared x again. So this will cancel. We remain with this. At least there's a hope there. At least there's a hope that we are going somewhere. So you can do that. All right, I'm going to explain if we can change sine squared. All right, but here there's a hope. So let us take this. So this is what we're going to do from the identity that 1 is equal to cos squared plus sine squared. It means we can substitute this. So this will be sine x minus sine x. Like I said, this is not an obvious case that you just substitute. No, test your simplification first. Does it reach far? If not, leave it, try another one. All right, that is to prove. So there we're going to have the cos of x. Remember, we said 1 is equivalent to this, which is cos squared x plus sine squared x. All right, sine squared x here. Okay, then there's a plus sine squared, which is already there, plus the sine squared of x. Let's see where are we going to reach. Let's see. All right, so we're going to expand. Like I said here, if we expand by the negative, so let's just write the numerator. We do not know that if we factorize, what's going to happen. Maybe we obtain the exact answer. So just leave it like that. We'll see later on. So here we're going to expand by the negative, just like what I did here. So this will be the cosine of x, negative times cos squared. That will be negative cos squared x, negative times a positive there. It becomes a positive, a negative, sorry, negative sine squared plus a sine squared, which is outside of the what? This is outside of the bracket. So it's not affected. So as you can see, these two, they do cancel here. Minus sine squared and sine squared x, they do cancel. So we are remaining with the sine of x minus the sine of x cos x. And a cos x, as you can see, there is something there. The sine of x is common. The sine of x is common here. The cos of x is also common. So we can do our factorization. From the numerator, if we factor out the sine of x, which is common, we divide sine x times sine x, and divide by sine x to get what? A 1. Minus this sine x and this sine x cancels, meaning to say you're going to remain with what? With a minus cos of x. The same thing in our denominator here. The cosine of x is common also. So we can factor out the cos of x. Factor out this, the cos and the cos, we get a 1. Minus cos squared divided by cos. This will be minus cos x. As we can see, there's a miracle that is happening here. The 1 minus cos x and the 1 minus cos x is gonna what? Is gonna cancel. We remain with sine x over cos x, and we know that the sine x over the cosine of x, it represents what? It represents the tan. That's the tan. All right. So we have got the tan of x there. So that is what we have. Is it what we have on the other side of our? Yes, that is exactly what we have on the right-hand side. So this is exactly what we have on the what? On the right-hand side. So this is equal to what? To the right-hand side. Just like that. Just like that. So you have to be very, very careful how you answer your questions, like I said before. All right, let's consider the other question. This was just a proof. So it's just a proof. As you can see, it was just a proof here. Okay, let's consider the other question. 2.5, they are saying, all right, 2.4 actually. This is 2.4. Okay, am I missing something here? All right, 2.4. 2.4 is the one that we worked out, but this is 4 marks, or this is 6 marks. All right, now I'm now checking like the number of marks, what is happening there. Okay, so 2.5, which is 6 marks, is the one that we are now. So on 2.5, they are saying, given that theta is an element of values from negative 360 up to what? Up to 90. Our solutions should be taken from negative 360 up to 90. Determine the values, the value of theta is supposed to be the values of theta there, if this is equal to. All right, so this is how we're going to solve this. From our general solution, because we are given there an interval. So we are given that the sine of 2 theta is equal to the cosine of theta plus 30 degrees. All right, remember what I said before. There is a relationship between a sine and a cos. These two, they are equal according to what we are given here, which is true. But remember, we can change this sign to be exactly a cos. How is that possible? The sine of x is equal to the cosine of 90 degrees minus x. Isn't it that we said before? That's exactly what we said. So meaning to say, if I have the sine of 2 theta, this is my x, which is 2 theta. It is going to be the cos of 90 minus x, which is our x. There's what? 2 theta. So in place of this sine 2 theta, we can write it as a cos. So this can be written as a cos of 90 degrees minus theta in this case, which is 2 theta. And this is equal to the cos that is already on the other side. You just change one side. So it's either you were going to change this one, you were going to change this to be a sine, or you change a sine to be a cos. It's up to you. Once you have this, you can equate these two. They are equal. But you don't just equate. All right, this side you're going to just take as it is, all right? 90 degrees minus 2 theta is equal to. So on the left-hand side, you're going to equate this to theta, which is theta plus 30 degrees. Then you add 360 degrees times k for our general solution. For a cos and for a sine, you add 360 plus k, 360 times k. For a tan alone is 180 times k. That's for a tan. Where k represents what? All of the integers that we can think about. Positive or negative what? Whole numbers. So it's a general solution which can give a solution in within this interval from negative 360 up to 90. We can find any there with this general solution. All right. So let's solve for theta first. Then we can apply our general solution. So what we can do, since here we've got a theta, a 2 theta here, we can transpose the theta, this one, the other side, so it becomes a negative theta. So it's negative 2 theta, negative theta. It gives us what? Negative 3 theta. All right, we can transpose the angle, the 90 degrees, to where other angle is, which is the angle of 30 degrees. So it will be a negative 30 degrees minus 90 degrees, which is what? Negative 60 degrees. So this will be equal to negative 60 degrees plus 360 degrees k. There's nothing that you're going to do on this one. So how do we find theta now? The theta here, we can divide by negative 3 by negative 3 by negative 3, each and every term that we are given. So the expression or the resultant that indicates theta is going to be given by this. That will be 20. If we divide 60 by 3, that's 20. Positive, negative, that's a negative 120 times k. So this is a new setup now. All right. This is now new. On this now, we are considering to say from the integers that we are given and the interval that we have from negative 360 up to 90. Remember our theta there is supposed to be taken from negative 360 up to 90 degrees. So you have to test the values, our integers, positive or what? Negative whole numbers. We can test if k is equal to minus 4, if k is equal to minus 3, if k is equal to minus 2, if k is equal to minus 1, if k is equal to 0, if k is equal to 1, if k is, you try as, guys, it's up to you. All right? It's up to you. As long it is going to be in within the interval, the solution must be taken. All right, this is what I'm trying to say. Theta is equal to, let's consider a condition where our k in this case is equivalent to 4. All right, let's start with this side. When it is a 4, we're going to start with positive. I want to check what is happening there. All right, let's say you have to check what exactly is happening. All right, this is it. We said let our k be equal to 4. Let me show you the screen of where we've got our calculator here. All right, so this is it. On your calculator, you're going to simplify 20 degrees. That's 20 minus 120 times k. We said let our k be what? Be 4. I want you to see what's going to happen there. Our answer is minus 460. Is minus 460 in the interval from minus 360 to 90? No, it's not. So when k is equal to 4, it does not work. We move on. Let our k be equal to 3. Let us put a 3 here. In place of k, we're going to put a 3. What do we get? Minus 340. Is minus 340 in within this interval from minus 360 to 90? Yes, it's in within. So minus 340 can be a solution. So theta is going to be equal to minus 340 degrees. Let's move on. Another integer after this, we are at minus what? We are at 3. Let's move on to 2. If k is equal to 2, we get minus 220. Minus 220 is still part of the solution, is still there. Minus 220 degrees. Let's move on. If our k this time is 1, in place of 2, you're going to put a 1. All right, what do we get? Sorry for that. Okay, that was 20 degrees minus 120 times a 1 like this. minus 120 times a 1. All right, so this is going to give us what? A negative 100. Negative 100 is still in within. From minus 360 to 90, we have minus 100. So minus 100 degrees is still part of the solution. We move on. We are at positive 1. So if we were now at 0, we are reducing. Remember, I started from 4, 3, 2, 1. So you're going to be at 0 this time. All right, guys. You see, this thing is just becoming slow. Maybe it's because of I have recorded for a long time. Sorry for that. All right. So this is going to give us, let's see, that's a negative what? Positive there. Positive 20. Is 20 in within the interval? Yes, it's there. 20 is less than 90. So you're going to take this solution. From there, remember we're at 0. We're now going to the negative values. All right. From 0, we get to negative 1. So if our k is negative 1, we get 140. Is 140 in within the interval? Our maximum value is supposed to be what? Is supposed to be a 90 degrees. All right. So meaning to say we no longer have this. All right. We no longer have this in our interval. We no longer have this. So we are not going to take this in our interval. We are going to end where? At 20 degrees. You take according to what you are given there. Guys, you have to be very, very careful. How you attempt your questions, you have to be very, very careful. All right. So these are the typical questions that you are going to have. And that was actually 6 marks for this. So like I said, you can even change a course to be assigned. Like this side, you have the same application. You are going to have the same answers. And also I said for the values, if you are using the general solution, if you are working with the general solution, for cos and for sine, we use plus 360k. For a tan, it will be 180 degrees times k. So please do not confuse, do not mix these two. Do not mix them. Know each and every part properly. So you need to first find the general solution with the information that you're given. From that general solution, you now substitute what? The integers. Substitute the values. I don't know which way are you going to take them, but these must be in within the interval that you're given. All right, so we shall see more questions to come from Meson African motives till we meet again.